Okay, everyone. Uh, Welcome to my first stream of creating a Java CMS. What basically this stream will also be visible afterwards on YouTube and as well as Twitch.tv as video, or that's the plan. So basically, what is a CMS? A CMS is a content management system, and what it does is it allows non-technical people to add pages, style a bit of pages, and create websites with content on there all by himself without the need to code. Um, so the basic architecture of our CMS will be we have an outer part and we have a publish part. On the outer part, the people, the non-technical people who will create the content will be on there, and they will create the content. And once they click publish on a page, the page goes to the publish server, and then it's visible for everyone to see. So basically, that's the high level view, the non-technical view. What will be some of the features that are more technical? The more technical features will be it will be component based. So we will have eventually a drag and drop interface where the author can drag and drop a component, and those components are reusable. You can drag and drop in on the page you want or like. It doesn't really matter. As well, for the author, they need to create websites, they need to create pages, drag and drop components, like I said, and they need to be able to publish the pages and also some caching. Also, the eventual purpose will be that it's easy to extend. So basically, what we will do, we will create a headless CMS and build on top of that headless CMS a front end. So a headless CMS is basically a CMS that returns JSON, and we will start building with Angular a front end for it, and that's mainly the publish, how we render our website that the author configured, because the author will just be an Angular application in one big jar. It will be just a jar. But I want also to support other frameworks like Vue and React, for example. Those are the two I know top of my head. So for the developer, we want to create components for our CMS really easily. We want to be able to use it as a headless CMS and a full CMS. We will also have a repository part, and the repository is where we store our servers. So how we will tackle this? Because I don't want to limit developers to create their own repository. We will create an API abstraction in Maven, but you will see it in the further on the streams. And we will start with a relational, an RMDBS, so relational database. But as we said, we create an abstraction API level, so we can also later on implement GCR. We can implement Mongo. It's yeah, the possibilities. The goal is to make it extendable real easy. So basically, we will have some duplicate data because of it, but it will be really small. As well, we want to set it up we will set it up with Maven, and we will also split it up in certain parts. So we will start with the core. We will create a new module in our project. By the way, we will use Java 8 still, because yeah, of backwards compatibility and stuff. It's the easiest. We will move to Java 9, 10 later on in the project. So yeah, it's 9, but I don't know if I have also an 8 installed, so I will use that one. So we will create a new module. and this will be a Maven module. By the way, hello Marulo. So we will create I'm from Belgium, by the way, so I will be calling it this. My CMS is called ZCMS because zwaldeck. So that's my base package, and then I will use core, and I have the first snapshot. I will save it under the core, finish, and we have our first Maven module. So you see we can add here our dependency management and all that stuff. So we can manage all the dependencies for our core in our parent. We won't need the source, and I will as well add a git ignore file. Git ignore, and now we search for JetBrains. This is a nice plugin, by the way. We search for Maven. We select it. Search for Java. And we select it. And then we say generate without duplicates. And then as well we say core. This also will go on a GitHub page, on the GitHub repository as well. But yeah, for now we don't have anything yet, so so I will first do the big layout in Maven. So we have no, that's a child. We want just a new one. Okay, next we have basically author. So we have .zcms author. Next. This will be basically a Spring Boot application with in there as well an Angular application. Hit apply. We will create another module. Also Maven. We have our repository. Oh. We say we and we really want these because I could make one main parent, the ZCMS parent, but I really want them to be separate of each other and have no dependency on, well, they can have dependency on each other, but also a bit separately. If it makes sense what I'm saying. By the way, if you have questions in the chat, just ask and I will see if I can answer them. The purpose of this project is that we learn both. And then the last parent project we will have is a utils. So, and this is just for utils that we can use in everywhere and could be handy. That's not really part of any specific point. Okay, I broke something already. Yep. What's wrong? What did I do? Uh-oh. I think I deleted the... Where did it go? Okay, there it is. So here we want the source. We already will create our ignore file. Git ignore. So JetBrains, Maven, and Java. generate without duplicates, and we as well utils.iml. Repository, we will split this up so we don't need the source. We add our git ignore file. So we have Java, JetBrains, Maven. Okay, generate without duplicates, and we say repository. We will also split this one up, so we have a new okay, ignore file, ignore, even Java, JetBrains. Okay, and we have outer.ime. Okay, let's start on the outer part. So we will have two modules here. Yes, we will use Spring Boot. Marullo, we will use Spring Boot. So we will have two parts here. We have a backend and a front end. So I will create a new module in here. Our Spring Boot application. Next. So we have e dot author, and then we have backend. Okay. Next. We want Lombok. We want, what do we want? Web. We want the web. And I think that's enough for the moment. Next. And we'll add it when we need it. Hi Alex. Okay. So we have our ignore file already. Yeah, looks good for the moment. These modules removed from the name description. No. Huh. Okay. There went something wrong, I guess. Well, dang it. Well, it's fine. It's fine. Okay. So we have our Spring Boot setup. Okay. We will do it a little bit differently. Okay. Backend. Next. Okay, so we have our backend POM. The outer module will be where the content, the guys who will use the CMS to create content. That's the outer part. So okay, yeah. So we'll have dependencies, and those dependencies here will go to here. Okay. Why doesn't it? Okay. So in here we have nothing yet. Let's see. We have this. We will add it a name. We'll also do it for the rest. Give it a name, but I will call it like this. Yeah, it doesn't see it as a well, it doesn't see it as a Maven folder. How does that work? Huh. Weird. So what? Ah, okay. Found it. Got to love IntelliJ. Okay, so now this is all added. We can add a new package. Okay. In here we want to wrap this in a dependency management. Okay, we have all this set up. Author application. Yeah, I didn't stream in a long time. It's true. That's enough to do. So we'll say add Spring Boot application public static void main, and we say Spring application dot run, and then we say author application dot class, and we pass in our args. And I did. It's this one. So now we will have our Spring application set up. So we can just run it as an application. We say author backend. Our main class is this one. Our working directory we will set later on. We need to select the module. Okay, apply. Okay. Okay, sorry. And we'll press play. Let's see if that works already. Okay, so we have our Spring application here. And we will add framework support for Spring Boot. If I can, IntelliJ, no, please. Dang it. Did I do it wrong? Okay, let's see. Well, the Spring Boot application works, but IntelliJ doesn't see it as a Spring application. Add framework support. Okay. Oh, not what I want. Okay, let's do it again. Let's remove outer completely. And do it correct this time. Oh, we still have a backend we don't need. Okay, so we add a new module again. We start with a Spring Boot this time. Don't care about the script. Okay, next. Let's not add anything yet. Okay, okay. Module. I don't see how we will do it, but it's not what I want. Okay. Basically, I want an empty Maven. No, Okay. We'll make an empty Maven. Next. Okay. So we have no entity there. There we will have our Spring stuff. So we have a packaging of POM. We will have modules. We have a parent. I think it's 2 I saw. Okay. And we have some plugins. I'll copy paste it. So we will have a Maven compiler plugin and we will have a frontend Maven plugin. Okay. Then we create a new module. Put as well a Maven module, and the parent is indeed outer. And we'll call it outer backend. Next, finish. Okay. We will as well put some dependencies in there, some Spring dependencies. What do we need? Start is these. Some basic dependencies. We will create a new class. Zwaldeck.cms.author. author application. And we create it, and we say it's an at Spring Boot application. No. Spring application.run author application.class args. Okay, we have our Spring create a new run config. Is it just an application, or do we need okay, that's what I do. Dang it. Sometimes I'm not the smartest guy alive. Okay, we will get somewhere this stream, I promise you guys. Okay, so the main class is this one, and that's all we need to do. Bye. Okay, now everything will look good. Now it will run as I want. So that's basically our API that will deliver the JSON to our application, the editing application. We will need to add a git ignore. Git here, and we have JetBrains. We have Java. We have Maven. Generate. Oh, dang it. Doesn't matter. And we also have author backend. We as well will give it a name. We say author / backend, which will look better here as well. This one will also have a name, and we call it author with a capital. We'll also do it for the rest eventually. So this will as well trigger it. So what is the final goal of this? It will be in the author. We don't want that it's two separate things, the client and the server. We want it packaged into one big fat monolithic jar, and that's why we will use the Maven frontend plugin. So for the client part, we will as well create a Maven module, which sounds weird because it will hold basically an Angular application. So it will be a Maven module. Let me say author-client. Next. So which is correct. So we will give it a name. And we will give it a build, which I will copy paste because it's way easier. Okay. So basically this is set up. We will need to add a git ignore. Nothing for Angular. TypeScript is not as well. JavaScript. Nope. Okay. Just add a git ignore file for generate the author client. Yeah, we had to add Maven. Add a template. Maven. Generate. Yep. And that's it. So now we go to our terminal. We cd into author and then client. It's author.net client. We do ng new. How do we call it? Let me get the docs up. Angular CLI docs. Documentation. Wiki. ng new. Okay, we have okay, new auto-count. We have a prefix. Our prefix will be CMS. And I basically want it inside that. Let's see if we can do it in the current folder. Dang it. Okay, yeah. Auto dash client. Okay, no, dang it. Git ignore already exists. Okay, we will delete it. Let the app generate. And let me drink. By the way, guys, if you have questions, just ask them, and I will try to answer them as good as I can. So now we're generating the Angular app for our CMS. Well, for our editing part of the CMS. I know we are still not getting into the code, but yeah, there is some stuff that needs to be done before we can get started to coding. And if IntelliJ wants to, yeah, it's indexing again. Great. So now, yeah, you see it generated everything I need inside the folder. and we will use it when needed. Come on, IntelliJ, we're waiting on you. Okay, so maybe I should already talk about how we will secure it. Basically, we will secure it using OAuth and Spring Security. And how we will provide the OAuth tokens with the JWT tokens, which stands for JSON Web Tokens. And there is a good website to view what it is and stuff. But it's built into Spring Security, and yeah, it just does a lot of stuff for you, and just need to work with Spring. Again, I'm a big Spring fan. So, without further ado, let's see if we can fire up our Angular application. Author frontend. We have start. Apply. Okay. Let's boot it up. It's building. And we have our Angular application in there. Yippee. So that's the setup for our Angular application. Let's shut it down because we won't need it for a long time, and that one as well. So let's start with our application. So, like I said, let's start with implementing the configuration for basically the security. Like this. So in our POM we need to add some dependencies. I also see I forgot to add the testing dependencies. Well, so we will add it. So let's say test. It's the first time I wrote it word right. And we say dependency or Spring Framework .boot. Boot starter test. And here, and then we say scope test. Nice. Okay. What else do we need? We have security already. We will need the dependency of our Spring security, and then we will need JWT. And we have another Spring security one .oauth, and we have OAuth 2. We don't need a version because Spring Boot's parent bomb already takes care of it. Okay. So we how OAuth works, we have an authorization part and a resource part. So the authorization does authorization and gives roles to all the users, and the resource part just checks if it can give back the resource or not. So we will create a new package called configuration, and we will start with security config. So we have a new class, security config, add configuration, enable web security, and we have an order security properties dot basic out order -2. I don't know why I'm doing it. I found it was on the web because of a problem and it works. Makes sense. Configure adapter. We will have a private final user details service, which we will have to implement. We have a private final password encoder, private final data source, Okay, now we will create a constructor with all those params, and we add autowire, and Spring will take care of it. Hi Dragon Dust, sorry, or Dragon Dust, I don't know. Drag 0 dust. Okay, so we will need to override some methods, configure, and with the HTTP security to begin, we need to say http.form login disable. We disable the login form. We say anonymous disabled, so we have no anonymous users. We disabled csrf.disable. We have the course, and we have HTTP basic, and we have an authorize request, any request, and it needs to be authenticated. So any request needs to be authenticated. Next up, we need to override again. We will do the web security, web.ignoring dot end matchers, and this one is a bit weird, and I will create first a class for it. New class URI access config, which will be final. And what the gist of this one is to add all the routes of our endpoints into this one. I will show it. So we will add our routes and as well our roles. So here we have the admin role, we need DOM role, we need public roles, and then we have a public media route. This is, for example, for images, because we will serve our images through our REST API. And then in here we say our media, well, basically this one. This one we need to ignore our web security, and we can just use it. We import it static, so we don't have to do URI access config dot. So that's that class. We will keep on updating it when we add routers to our API. So yeah, you could not outwire the password encoder, and then yeah, we will get there. No worries. Next up is an override, and it's the Authentication Manager builder. So we say out dot user detail service is the user detail service, and the password encoder is the password encoder. That's done. Then we need to create a bean, public authentication manager, Authentication Manager bean. And return super dot Authentication Manager bean. And add throws exceptions to there. Then for our CORS, we need to do some work. So we'll have a new bean, public course filter, URL based course configuration source. We say course configuration, config, and then we will basically add an easy one. So we say config dot set allowed credentials to true, and then we say config dot set allowed origins to a star for now. Origin, sorry. Apparently it's better to use a singleton list. Great. Okay, and we have allow. Okay, I see where I went wrong. I think they have an add method. So config add origin star config dot add header allowed header is a star. We add another one dot add allowed method star and source dot register configuration for all paths with config, then return a new with source. Done and done. And I have a problem. I imported the wrong one, I think. This one. Okay. So this will handle our CORS. As you can see, we still need to set up our password encoder and our data source as well. Okay. Pum pum. Let's see. Okay, yeah, maybe we should do that first. Let's set up our password encoder. So we have a Java class and we have a new web config. Okay, and our web config will implement web MVC configure. Oh, maybe we should just extend from the adapter. Oh, it's deprecated. Why is it deprecated? Implementation. Marullo, the code will be indeed in a public repository. I will add it somewhere as a panel, and I will mention as well at the end of the stream. I will mention it as well. But I will create, yeah, every Maven parent module will be a separate repository, but it will be in a project in GitHub. So we can use it like that, or maybe Bitbucket. I'm not sure where I will host it, but it will be hosted somewhere publicly. So it's deprecated as of 5.0. Then, oh yeah, okay, so because of the default methods, which makes sense. Bang. We override the add arguments resolver because I want a pageable I can't type, man. We need to add a Maven dependency. Yeah. Okay, we need to add the dependency, which is this one. Security stuff. Okay. Come on, IntelliJ, you can do it. Solving dependencies, I know. Oh yeah, I even forgot its method argument. Spring is really great with their names. It's not long as or something. We have a fallback pageable and we create a page request of page 0 and we have a default size of 50. We have bar set or one indexed true and argument resolvers. Okay. We need to do some more for security as well. For our CORS, we need to edit. Now we say registry dot add mapping for every route. Allow origins. Allowed headers. I think the other bean we created, it's more for Spring security, and this one is for Spring in general. So we say options, get, post, put, and delete. Those we will support. And then we say allow credentials true. We will as well create another bean for some mapping JSON to HTTP message converter, which will configure some default object mapper config. Fail on empty beans. is false. Okay. Then we return a new object with a long ass name and then the mapper. And then we will have a public password encoder, because we needed that one. And then we have return password encoder factories dot create delegating password encoder. Okay. So we are trying to fill in. Well, we have a data source. Great. Where does it fetch it? Normally it should find a password encoder now, eh? Ah, it's weird it found data source because we did not configure that one just yet. But okay. Maybe we should be start doing that one. So we will basically need to configure our data source, but our data source will live in the core. Sorry, in the repository. So I will create a new Java class, rmdbs config, which will only work with the profile. And we'll call the profile rmdbs. We have our configuration. And then we have another import. And this import should eventually go to our repository and our rmdbs config there. So, well, basically we need our repository implemented already now for users, so we can, because we need our, like I said, we need a user detail service implemented. Sorry. And our user detail service needs to have data. And data comes from the repository. So in the repository, we will add a new module. Sorry. So we will add a new module. We have our parent repository, repository-api. Next. And we'll give it a name. And that's it. We will have eventually dependencies in there. What we can do, and that's maybe not such a bad idea, is all as well import Spring Boot in there, because our backends, every backend we'll create for the CMS will basically use Spring Boot classes, well, Spring classes, and yeah, we can easily access them from the Spring Boot. So we will say we have this, and then we have as well dependency management. Which will be filled in. What's the first dependency I can think of we will need? That's Lombok. If you guys don't know Lombok, get to know it. It's freaking awesome. It takes away a lot of boilerplate code that you don't need to do. So Lombok, and we have Lombok, the latest one. We copy it. So the dependency management, if someone doesn't know how it works, just shoot a question and I'll explain it. But basically, now we can add our Lombok here without our version, because we will manage our versions here. Okay, I explained it already. Lol. So our repository has now Lombok. Okay. So we will start with our user details service. So we will say we have a new class. We dot then it's the CMS dot repository dot API dot service. Yeah. Okay. That's a package, of course. Okay. Let's create. Okay. Let's create a package first. cms.repository.api.model. Okay. And we will create our user model. So this is our model, and we add data. It's from Lombok, which will make sure it has the getters and setters. So for our IDs, we will use UUIDs, so it will be all strings. Then we have a list of a role, which we will need to implement. And I will already do that. So a role will be an enum. What roles will we have? We have a role client to get the OAuth token. We have a role public. We have a role admin. We have a role author. We have a role DOM manager. The DOM stands for Digital Assets Manager. We will create one in our CMS. So I already implementing it here. So then we need to import the list, of course. What will this user as well have? Private string, no surprise, a username. Private string, a password. And then we have a private date created at, and import the date, private date updated at. Okay, and this user will then implement user details. Okay. So we need to add the Spring security. Yeah, okay, add it. So and we add it as well here. Oh yeah, we can just add it directly to there. Yeah. We don't need to do it here because we already have the Spring Boot. Don't get why it's compile. Let's remove it. Put it there. Okay. Nice. So now we can access that file. We need to implement some methods. So this will be implemented later on. It's nothing for now. And we have this one. So we say roles.stream. We map it. So we have a role and then new simple granted authority. And we say role.name. And then we collect it, which will work fine. Okay. So this is our user and our model, and as you can see, we don't need to get the headers etc because of the Lombok at data. So we will need a new service, Java class service dot user service. Add it. Needs to be an interface. And this one implements extends user details service. Yeah, this is fine for now. So this is our model for our user, and our security will also use it. What do we also want? Well, now we need to basically implement this. So I will close everything here. We will work a bit on the repository. So we'll need a new module in there. And then we have repository dash dbs. Next, finish. So in here, we will do the repository in a relational database, or that's at least a point to it. Eventually, we will support more relational databases, but for now, I will start with the MySQL. And because this dependency is not shared, because MySQL is really a standalone one, we will just add it there, and use it. Well, we will use MySQL 8. It will work. Probably it will work. We'll see. Else we go down. So we add a version here because it won't be shared over the. Well, we only will use it in this package, so we put it here. After that, we need some config. So we'll add a base package dot dbs.config. Dang it. I wanted one package more. Doesn't matter. Config dot data source config. Oh yeah, no, wait. rmdbs config. So basically this config, I need to annotate it. It's not added yet. Why not? Because we don't have anything to do with Spring Boot just yet. But if we add this dependency we have and we need it, so now we will be able to. Oh. What is this stuff, man? Parent will go. It should be able to get it because of this dependency, but it doesn't. Why? See, there's a Spring Boot starter, so we have the dependencies. It should work, but it doesn't. Re-import. Now it does. Great. Thanks. Thank you very much. Okay, so we will use this config in our outer. We will as well put a profile on it, so it's only loaded when we choose to. rmdbs. We will have a component scan, and we have a base package on there. We will use this one as a base package. We have an entity scan on there, and this one will be domain, which we will still need to create, and I already will create it. We will also need a domain access object, some DAO, yeah. Let's enable GPA repositories, so we can use just interfaces and not implement anything. It will be basically this package, but DAO. Yeah. No application configure it. Done. So basically we will need to load in the config from somewhere, so we'll create a Java class, a data source config, and we add Lombok, Yep, we need to add Lombok. So we have dependencies. I think Lombok, and then we say scope provided. And we have data. So we have a database type. Database type. We'll create it now. And this is basically an enum, which says MySQL or Postgres or any other relational database we have implemented. But yeah, we could keep it for MySQL for now. That's our database type. We have a private string host, private int port, private string database name. We have a private boolean use SSL. We have a private string username, and we have a private string password. That's how we do it. So basically what we want to do is loading the config from a JSON file. That's our end goal. We will do it basically. So we will have a post construct, public void init. We have a private data source config, and in our post construct we say JSON config utils dot load config. We give it a path in our working directory. And we say it's a data source config.class. We will need to create this one. This one is a good example to go into our utils because we can reuse it. Which we will do. So in our utils, our POM is not correct. What's wrong with it? Oh. Oops. Okay. So we have dependencies in here. Okay. Here we have our e.zwaldeck.zwcms.utils. That's it. Fuck. Nope. Beep it out. Beep. Nope. F word. Utils. Okay. We forgot to change the name here. Utils. JSON config class. It's a final class. We have a private constructor as well, so no one can. Okay. God dang indexing. Half the time you do is waiting on IntelliJ. Pam 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 pam. Come on, IntelliJ. And this is the first thing we will start to write tests for it. Well, it's difficult. Oh, it isn't. Okay. Yeah. We're done. Let me see, utils. Okay. So what this will do is we have a public static, some generic stuff. So this will return t, load config, string file path, and we have then a class t class throws. Where did I? Let's create a nice config exception and some default constructors as well. We want this one and this one. We don't need more. And it's an exception. Yeah. Because we want to crash. So we have a path. The neo path equals paths dot get, import it, get IntelliJ. You're not having you're not helping me today, IntelliJ. File path. Now we can do some tests on it. So if the file doesn't exist, we throw an error, throw new config exception, and we say file path doesn't exist. If files dot is directory path or file dot get extension file name utils add Maven dependency. We will add the Apache Commons file name utils dot get extension from the file path equals ignore case JSON. So if it's not a JSON file, man, I just changed it. Don't change it back. Thank you. We say throw new config exception, file path, not a JSON file. Now we have a try catch. AO exception. Now we say throw new config exception. There went something wrong while parsing config, the config for we say the file path, and we add our exception as well. Boosh. And here it's easy object mapper. Add Maven dependency. It's 2-piece. Check some data binding. We add it. Mapper equals new. Why does it do that? And then we say we return the mapper dot read value path to file and then class, and that framework will take care of it for us. And this one works. So how do we know it works? We write tests for it, of course. Unit tests. And we have JUnit 5. It's not found yet. Okay, let's first add the test dependencies. So we search for Jupyter engine. We have the 5.2. Nice. Where is our com? And we will add Mockito. Okay. We will add the Mockito core. Nice. Mockito core is added. Then we can generate our basic test already. Does anyone know why IntelliJ is doing that to me? I don't want to go every time. Okay, I will take a short break, guys. I will be back in 3 to 5 minutes. Hey guys, I'm back. Okay. Cool. Let's create the tests for this one. Create tests. Okay. So we will have a test when it's not existing. So we have a throwable t, assert throws, config, exception class, and we have a lambda there, JSON config utils dot JSON. Check.class. We will format it a little bit better. Okay. And then we say assert equals. What do we expect? We expect file doesn't exist dot JSON doesn't exist. That's what we expect. T get message. Okay. Read or not? Oh, that's why. No. Why? Where do we have we have 1.8 here, which is fine. Where does this error come from? Build project. Okay, we have this one. We don't have a 1.9 SDK. Okay. Come on. Where does it come from, guys? Any help? Dang it. Do I need to add plugin as well? No. What? Okay. Why are they all on the 9? So now we added the Maven dependency. No. Ah, we added it. Yeah. Okay. Back on track. Okay, back on track. Back on track. Yeah. We'll comment this one out for now. Oh. Reopen. Okay, now we can test our test. It failed. See, that's why we have tests. Typo. Run it again. Huh. This looks pretty much the same. So what's different? Huh. Typo. A lot of typos today. Great. Okay, so basically that's the first if. What is the next one? We need to test if it's a directory. Then we have the error. That's the next one. Void load config. So that's how I create tests. That's my own convention. I have the method name, then an underscore what the test is about. So directory. We can copy paste it a bit. We say /home. It won't work everywhere. It won't work on a Windows. System dot get property. Does anyone know Java properties? System Java properties. Okay. User dir. This will always work. Doesn't matter where you run it. And then we have a file. It's not a JSON file. And we need to get this one again. Yeah, I have this. Let's run it. Yeah, green. Okay. So that's this part of the if statement, and then we need to test this part. So let me copy paste my test. No JSON. So the file needs to exist. So I will just create a file in my resources for my test. So new directory resources. Man, I can type today. Resources. And we mark the directory as test resources. and we create a file config.txt. Nothing in there. With nothing in there, literally. Then we have config.txt, which will now be green. Nope, because I didn't do this part. Now it will be green. Nope. Okay. It doesn't exist. Oh. Okay. I know where I went wrong. Okay. Now it will work. Now we say file path. Yeah. So these two if statements are covered. Now try catch. How do we test it? Well, we just create an invalid JSON. That's it. So we say file config invalid JSON. So this is an invalid JSON. So valid JSON, we will load in config underscore invalid JSON, and then there went something wrong while parsing the config4, and file path, let's copy paste it. Douche. And now this will work. And now we need to test a valid config, so we will add a test config class. Yeah. No. We will not do it like that. It's not a good idea. We will create a public class. Test config. We have a name. Private string name equals ZCMS. We just need to test if it has the JSON with that type. We don't want to test if everything is correct, if the JSON parsing was correct, because the framework takes care of it, so we don't need to test the framework already. Load config underscore success. And then we have this one. Call it valid. Copy paste this one. Call it valid. Remove the invalid stuff. We say test config equals JSON config util load config file path test config.class exception there, and then we say assert equals ZCMS and then config.name. We can exit. Let's test it out. We need getters and setters, I think. Yep. So what will we do? We will add Lombok. To this one. Hello, Lombok. And then we go here and we say data to run it. Cannot construct instance of policy non-static inner classes by using default. No argument. I have an ORX constructor. Huh. Why? Oh, okay. I'm not going to search for it because it just tests. Boosh. Ah, okay. Now it's all green. Now we run it with coverage and see how much we have. But it should be everything. And let's see. Yeah, we have everything. You can see here 100. Okay. So that's our JSON config utils. So back to our config. So we say here that we want to load it in. Bum, bum, bum. And then we want to create our data source and stuff. Everything for the string data, GPA stuff. So we'll say add bean. It will be a primary bean. Public data source. Data source. And then we return data source builder dot create. So our URL, and then we say build connection URL config dot username config dot get username password config dot get password dot driver class name get driver will also be this type. The driver will also be a private method. Yeah, it will be a private method. Now we say dot build done and done. So the first one is a private string build. This one. We get a config in there. So And then we add to our connection string get connection URL type config.getDatabase type, and we add. So this one will return Postgres, MySQL, and all that stuff. So another method, connection string plus equals config get host config dot get port. So we have the host and the port. Then we have a connection string with the database name. And then we append our connection string with the use SSL. And then it's config.use SSL, and we return the connection string. So we missed two methods. So private void get connection type URL, database type, this should speak for itself. And of course it's not a void, but it's a string. Format it. Let's copy paste. Okay, and then we have the get driver. This one is or.postgres.driver, and the MySQL one is com.mysql.gdbc.driver. Oh, it's no duplicate. So that will build our data source for us. So what's next is the Entitymanager Factory that we need to set up. So this is also an admin and a primary, so we override it. Public local container and factory bean. So the long names of Spring come into play. I call it EMF. We set the data source to data source. EMF will set packages to scan. Get EMF packages to scan. We will create an array list there. So for now it's just our domain, but it needs to be extended. It needs to come from the config as well. So we add an array of packages to scan. And get EMF packages to scan, and we will send our config. We have private. What does it need? It needs an array of packages. Okay. So basically, we already have an array in our in our config. So we say list string packages to scan equals to arrays to list as list. Sorry, config dot packages to scan, and then we say packages to scan dot add, and we need to scan our own packages as well because we will need it. So we add it to our list, and then we return our packages to scan to array new string of 0, and that will give our package to scan, and we can add it in the config as well, so developers can extend it and use their own packages for their components. Always keep the developers in mind when building a CMS. So now we'll say EMF will set persistence unit name ZCMS EMF dot then we need a GPA vendor, a GPA properties, and that's it. So we will create an hibernate GPA vendor adapter, call it va dot set show SQL is true, va dot set generate DDL is false. Then we have our properties, our GPA properties as well. So we create a GPA properties equals new properties. And in GPA properties, we put hibernate.dialect and get hibernate dialect config database type, and then we have another one that put now let me say hibernate dot hbm to DLL auto create dash drop, but we won't use it yet. We use it when we really need to, but now we restart our stuff. We will basically create a service for it. So basically, when the database is not created or not completely implemented, it misses some. We will do a create drop, but we will do it programmatically and not via this one because now because we don't want it every time we restart to create drop it and lose all our data. So emf dot set GPA vendor adapter va emf dot set properties, GPA properties of course, and emf after property set we return our emf variable. We just need to implement the get hibernate dialect, which is also a string, private string, get hibernate dialect of our database type. And it's basically this one again. But where do they live? Org dot hibernate dot dialect post SQL 8.2 dialect. Hibernate dialect dot my SQL dialect. And you can find it basically in your libraries if you go to org hibernate. Is it common? Is it common? Nope, not common. No need Java persistence. Nope. Hibernate core. Then you have here dialect, and then you can see for MySQL we can use this one, which gives basically a MySQL dialect back 5.7. Yeah, and we have also a Postgres. We could use 9.995, I guess. Maybe better. 9.5 dialect, and that will do it. We as well can use MariaDB, Oracle, SQL Server, etc. And we will do eventually, but for now it's enough to make MySQL work, basically, and then we can use our framework. So that's our EMF. And then there is something I'm just going to copy paste because it's not really well, yeah, we need it. We need our settings again for our how do we say, yeah, for our database creation when there is a table not there, if you get the flow. So this will load in our relational database config. So now we can basically implement our user here and our service. So we will implement our service, but first we need to have yeah, we need to have another model which represents the user again. I know it sounds weird, but our API is our highest level, but because we also want to implement GCR and stuff, or some other type of repository, I don't know which one you can think of, but it could be that it's not GPA supported. That's why we create well, we have a Spring part in there, which is we are able to, but not the GPA stuff. So that's why we create a new one. So we have just empty objects. That's the point. Our user service has the user detail service, but that's of the Spring security and not of the GPA. We want the GPA stuff only to exist where it needs to. So that's why we have the domain, and yeah, we need to have it again with the proper annotations and stuff. So we will call it user DB for now, because it's from a database, RMDB, so it's so long. So it's basically an entity. It has a table, and the name is the user table. and it has data annotation. So basically, what does this one needs to represent? This one, so it will have all the variables again. So we will copy paste it. It maybe sounds dumb, but it really isn't. No role. We have a dependency on that one. Yeah. So we have a dependency on our API as well. And now we see we have already 2 times my the version here of our API. For the utils, it's easy to add it to our parent, which we should do. So we will do it. So we'll add it to our parent POM. And in here we will create the properties. And on 1.0 there's snapshot. So now we will use the why? Oh yeah, okay. And then we use the property, which is better. We cannot do it for the API in there because it would create circle stuffy. But here we can remove the version, but we can use another property dot road parent dot version. And normally it should just go to the parent, see what version it is, and get that one. So that's set up. Now we can import role from where we need to. So now it's time for the annotations. So this one is the ID. Generate set value. We have the generate UUID 2. At generic generator. We have the name UUID 2. And strategy is as well UUID 2. The roles is we will put an at enumerated, and we will enum type string. So the roles we will save in as a string. We have an element collection as well, and we are eager to fetch it. And then we say collections table name is user underscore roles table. Join columns at join column name user underscore ID reference column name ID. Okay. And then at column name username needs to be unique. It's not nullable. Our password doesn't need to be unique, but it's not nullable. At column created underscore at nullable is false. This needs to be the name. Updated at. And then we, because it's a date and we need to, yeah, temporal, it will just go to timestamp. So it knows how to save and retrieve it from the database. If there is anything I just did that doesn't make sense or you don't get it, don't be afraid to ask it. I can probably give a good answer why we do it. Then we have a persist. Public void persist. This dot created at equals new date. This dot updated at equals a new date. And we have a pre-update. Public void pre-update. This dot update at equals new date. So this is our object we can work with in our service. But there is a problem when we will start implementing our service. As you can see here, we will implement this service in our repository RMDBS implementation. But it will eventually return, that's the goal, the plain old user that we in the API develop. So we'll need to write converters for these classes. And converters are real simple. So I will create one. And for the converters, I will not write tests. Those guys are way too. Yeah, there is just not. It's not logic that. Yeah. It's. In my point of view, it doesn't have any point of testing it because there is no logic at all in there. And I only test useful stuff. So we have a package converter and we say user converter RMDBS. And this one is we have a component. We will as well create an interface for it. Why not? Okay, so that's the API and that's DB, and then we have DB to DB, and we accept an API entity, and we accept a boolean update. Then we have API to from DB. We accept a DB. Okay. We implement a converter. Our API is user and a user DB. Implement methods. Boom. And yeah, so basically these classes won't get loaded if we don't use the profile RMDBS because our package postgame is also as well on there. So in here we need to create a user DB. DB equals new user DB. Then if it's an update, we need to set db.setID from the entity.getID and db.set created at entity.getCreated at. Then the db.set username. We have entity.getUsername, db.set roles, entity.getRoles, db.set password, entity.getPassword, and we turn our db. The same we do here, user entity equals new user, entity.setID equals db.get ID, entity.set username, db.get username, entity.set password, db.get password, entity.set roles, db.get roles, created set created at db.get created at set updated at db. So if anyone knows a better approach for this, and I can keep still the API without all the annotations, let me please know, because I kinda like it, but it's not ideal, I think, and I will see if I can refactor it away with some reflections and stuff, but reflection has a huge hit on the performance, so it's always a bit will we use performance or do we have more code? It's a bit, for now this will work fine, but it's not ready yet. So now it's time for the service. So we have new class service dot, and we have user service rmdbs. Okay. This service implements user service. Implement methods. For now, it's only one. We are missing something. As well needs DAO, and this one is an interface. User DAO. Okay, and it extends GPA repository user db, and the ID is a string, and that's it. And then we use an optional user db find by username. And that's all to query our database. So if anyone doesn't know what the GPA repository does, ask it and I will explain. Final user DAO. We will have private final user. We need to use the variable name. We have user converter. Then we create a constructor and we add auto wire there, which will wire it. Then we have a find defined user details. And then yeah, so basically I don't like that it's returning the object. I wanted this service to return optionals. And I will just implement another method that does the same and just refresh it, but use an optional. So optional user get user by username and string username. So we need to implement this one. Basically what we need to do here is user dot find my username, and then we map it. We say converter from DB, and that magically works. Then we say here get username with the username. Yeah, okay, our variable now is s. But then it returns optional, but we can do an or else and then just return null, and that's how it's implemented for Spring. Yeah, I really like the optional, so we can do the map and the code is way cleaner. But it should throw a username not found, of course. Or else throw, of course. Like this then. Yeah. No user found with username. Okay. So we need to test this one. Because this is an important service. But yeah. It's not that hard. We will create a test here. We need to have our dependencies. So we will add it to our parent. And then as well to our child here. But we will remove versions. Okay. So we'll do this one, create it. Now we have two methods. So for the first one, get username by ID, we have two cases. Or it finds one or it doesn't. So the first one is success. Well, we need to first do an mock private user DAO, so we can mock it. What else do we need to mock? We need to. We don't need to mock anything anymore, but we need a private user converter. Now we say at before each void setup Mockito annotations.initMocks site the user converter equals no user converter. It's no dependencies, which is nice. So now we can say when and it's static method of Mockito when the user dot find by username and we will have any string. Then return an optional of get user db. It's a private method created. User db. We only set one property, it's more than enough. Okay. So then we say assert true. Private user service, of course. RMDBS user service equals no user service. We have the user DAO and the user converter in there. Get by username user dot is present. This will give true. I'm sure of it. It would suck if now it fails. Empty. Yeah. Okay. What? Okay, there is something going wrong. Doesn't matter. Already implement the next test and then see what's going on here. Oh yeah, okay, okay, I see. I think I see what I did. No, I don't see it. User service. Now we do find by username, which we have. So why doesn't it return anything? Any string and return, which is correct, an optional of. Then we have to get the user, which is a user. Okay. Okay, that's correct. Just name, which is fine. Close. So our got it. So that's why we write test to find the bugs. Whew. The older one. Let's test it out. Yeah. Okay. Here. So we do a success one. Oh, ik dacht het. Oh ja. We do an assert, not null. Oh, I'm getting tired, guys. Okay, that works. And then not found, of course. Not found. Then return optional of empty. Then the other test had throwable stuff, which is way easier to copy paste as an example. Run the test. Nice. Nice. Okay, so we will run it with coverage. It will cover the whole damn service. Add it to active suites. 100. Okay. So our user service is done. So basically we wired it up to be used in our author. Well, didn't wire up our database and stuff yet, but so in here we have our config, and now in here we do import we have then rmdb config. zwaldeck.zcms repository rmdbs config rmdbs config. Dang it, I wrote it wrong, I guess. Oh, it doesn't matter. So we will do the same as here. So we add properties to our parent, and our parent is here. So here we have, yeah, we don't do it here because our author, the second one, is just a client. It's makes no sense to do it there. But now we can add our repository. So we can do we need the API, but of course we as well need the implementation of it, because else we cannot access the config. Yeah, we need a version. We need a version. Dang it! See, I'm getting real tired. So so we need to add that one as well. There we have that. Close, close, close. And we will add this one. Dot class. And this will make sure that basically this config in our outer loads in this config. Now it will crash because we don't have our JSON yet. And that makes sure that it's set up. So basically, what do I want to do still before I leave the stream is one thing. We will have a setup service in our repository. So we want our application to boot itself up when it's not and create itself when it's not existed yet. Well, yeah, it's a bit weird to say, but when the database does not exist, we want to set it up, but we want to do it for every repository. So we will create an interface setup service. A setup service. And it basically has a boolean is repository. Repository setup. And it has a void setup repository. It could, the is repository setup could also be a private method, but I want to make it public to developers so they can also as well use it if they want to for some reason. Yeah, and this one basically will set up our database. So we'll set up service or MDBS. Now we have a service implements setup service. Implement the methods. So basically, what will we do in here? We will see if all the tables exist. But we will, yeah, add a lot. So we will need as well a lot in here. So at autowired, we have a public setup service RMBS. Well, we'll need our data source. We will need our password encoder because we will create a user, an admin user as well. So we will create a user. This means that we need a user service, our user service. Yeah. And for now, that's it. And create field, push. Could not auto wire user service. Okay. No beans password encoder found. Why not? It finds it from there. Yeah, it just says it doesn't get it, but he gets it. So how can we check if the tables, if it is the repository set up? So basically, we have a few things there. So we need to check if all the tables exist, and we need to check if all our data that we initially need exists. That's what we need to do. So we will create an array list of string tables in db equals a new array list. Then we have a result set, and then we say data source dot get connection, get metadata dot get tables null. This can also be null. Then we have a table name pattern is all and types null. And then this as well needs to be in a big try catch. Then we need as well a new exception. So we'll extend exception, because if we have a SQL exception, we need to throw it, but we cannot throw the exception true, because then our top level will depend on SQL, which is not good. So we will create our own exception, which will convert it, and then we say here throw new SQL exception, which then says there went something wrong. En dan zegt je hey, exception. Method signature, yes. No, 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 no. Go up. This one throws exception. Yeah. Throws exception. No, 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 no. Repository exception. That's why we created it. Okay. So then we have the result set. What we then need to do, well, if we get here, we return true, then it exists. While the result set dot next tables in db dot add result set get string table underscore name, and then we need to check it. So we need a list of all our tables in there. So we create private static final string tables needed, which is an array. And the first table is users table, and as well user underscore roles underscore table. Yeah. So then for string table tables needed, if tables in db contains table, return false. So that's the first part, checking that all the tables. Then I'll add some comment, check if admin user exists. So we will have a user admin equals user service dot get user by username. Now we have admin. Okay, it's an optional. If the user doesn't exist, if admin is present, or admin dot get username get roles. The role admin, sorry. Then it's as well false because we need to set up our admin, and our admin user cannot be okay, so that's it. Then we have our setup repository, which is a little bit trickier, I guess. So basically what we want to do is let Hibernate generate our database schema and create it. And then we create an admin user. So how do we do it? So we have a meta data sources, metadata sources, equals new metadata sources, new standard registry builder, might be the worst. Standard new builder dot apply settings, but we don't have the settings yet. Dot build. So earlier in the stream we created something called the raw settings map, and this is the settings we need. So basically we need to import it through our constructor. So we say add qualifier raw settings map string comma string import, and we say raw settings. Okay. So that creates our metadata sources. Then we need to add all our database classes. So add annotated class userdb.class. Oh, we need to do raw settings there. And yeah, the more classes we create, we need to update this one. Then we have a schema export, which is pretty neat. Dot set halt on error false, set format true, schema export, set delimiter a semicolon, schema export execute, enum set of data target type dot database. I don't want the script. Then we have action boat, metadata sources build metadata. So that will create our schema, and then what we need to do is create a new user, admin equals new user admin dot set username is admin dot set password is then password encoder dot encode admin dot set roles arrays as list. We want it to have it all the roles. Then we say user service dot create admin. So one last method to implement, and then the service will work. This is the cliffhanger. I hope to see you guys next stream. If you enjoyed it, please feel free to subscribe. Share it with your friends that also program. Next stream we will work. We'll finish this one. We'll finish our OAuth setup. We will have our first JSON call, and I hopefully can start a little bit already on the front end, so you guys can see what theme to use and stuff. I enjoyed the stream. I hope you guys did too. And if there are any comments, just private message me, and I will read them. See you guys. Bye bye.